Hello, welcome back. Today, another day, struggle with KiCAD. We missed yesterday. I was a little bit busy with some other stuff, but today we are back with full force and most probably no progress as usual, but nothing to be afraid of. This is how things go. Okay, looks like I am live, checking if everything is okay. As usual, I was tweaking the stream yesterday, and I'm kind of worried that it might die halfway through, but okay, so far so good. Okay, let's get to work. No time to lose. Alright, so last time you were struggling to get the PCB done. So what we only managed to do was to place this resistor that is meant to be for the infrared. So this is a pull-up to 5 volts, and this should go to the collector on the diode. So there was no symbol for the diode. That kind of sucks. Also, there was a footprint, but not the one that we really need. So we have to figure out something else. I did some reading yesterday, and it looks like we can technically use some other footprint that will fit. I mean, it doesn't really have to be footprint that is exactly for the same component. So for example, right here, where we planning to the diode, so we can just put on the PCB, we can use a footprint that is meant for a test point or something like that. And this should work. It's a little bit different compared to EasyEDA. EasyEDA is much simpler, much easier to use, because all of the components actually, they all have a footprint attached to them. So whatever you use, you get a footprint, and then on the PCB you can either use this footprint or you can just attach some random pads. You can place them however they suit you, and you can just remove the original footprint, just to be mindful to keep all the same nets the same, and it will work just fine, no issue. KiCAD is a little bit different. Maybe I'm not that well versed in it yet. I'm just starting. My latest development was this encoder, and this is just one element. Yeah, and other than that, I'm still very fresh to KiCAD. Yeah, so we have no fin for the diode, and we also need I2C expander. So I was looking into this I2C expander. So if I am correct, we'll be using this one. The size doesn't quite check out. I just found it, and it's 8 millimeters. This one is 7.5. But looking at different sizes, this one's 5.3, so this is definitely not what we have. 8.4. Okay, let's take a look one more time, because okay, SO24. You're right, D. Okay, so maybe I was maybe it's not that much off. So we have to look at this this size. So D for this one, SO24. It looks like D is 15. Okay, so that's not the one. So it looks like I have this one, SSOP24, because D for my element was 8. Yeah. Yeah, so yeah, this will check out. So ours is SSOP24. So I was thinking maybe we can make a symbol for the I2C expander, unless there is one already. Let's take a look. Let's see, symbol editor. Do we have something? Let's say expander. Interface. Expansion. This looks kind of similar. The name is a little bit different, TCA, but 9555 PWR. Oh, looks like we have one, so this should be it. Okay, let's place it. Yeah, looks like... Yeah, and the package checks out TSSOP24. Okay, so that is good. I thought that we will have to make it one ourselves. Looks like we don't have to do it. It's derived. Okay, I guess I don't really care if it's derived or not. Okay, as long as I can use it. Okay, this makes me kind of quite happy. Okay, so there are a few things we need to take care of. There is a schematic over here, how to connect this thing. Yeah, so mostly it's simple stuff. What we need to take notice of are those resistors. So these are pull-up resistors for the I2C interface. So I think it depends on the device, because for example, for the one that I've been using for Chordie, the breadboard or the breakout board, MCP 23017, I think for this one, I think it's 4.7 kilo, and this one is 10. So okay, that is fine. So we need those as well. So we have to pull up all those 3 pins over here. Okay, this one is VCC. Can I copy and paste this one? Okay, so we have VCC, we need ground. It's all a little bit weird. Okay, let's attach ground. All right, so we have that going. Okay, over here we have address. So I think we can do it a little bit different. Let's move this. Let's move this over here. Can I edit something? Okay, reference U1. Okay, let's make it, let's make this one left. So we have to be mindful of the address and all this stuff. Okay, this resistor, do we have a footprint for it already? Oh yeah, okay, so it's gonna be the same thing. So let's yank it from here. Okay, we need 3 of these. Okay, we can either keep it over here, or maybe we can do it like with a net. So we can just make a net and keep all of them somewhere up. So this will be like all the pull-up resistors that we have. Okay, let's take a look if we can do it like this. I always start my project neat and clean. Everything is super clean, and like 10 elements in, it's a complete mess. I'm pretty much sure it's gonna end up the same over here. I'm starting with good intentions and then everything goes to shit. Okay, you can do place repeated copies like this. Alrighty, so these are all 10K. It would be nice to give them some good names. Okay, wrong. It's not supposed to go to the ground. My bad. We're gonna need a net for that. Net label. Let's call it maybe let's make it like maybe let's do like R pull up make it SDA. And over here, I think we can make the same net. Okay. I hope this is canon for KiCAD. I hope I'm allowed to do it like this. It's gonna be funny when we do like connection check. I hope it won't kill the whole KiCAD after all this mess. Alrighty, so this is one net, so one more. Okay, let's call this one R pull up SCL. And let's add it here as well. Okay, so far looking good. And we have one more. This one is, I think it's an interrupt. So this will trigger when there is something, when one of the inputs on this side changes. So this is kind of neat because you don't have to poll all the time for the registers to check if there was a change. This will kind of announce it that there was a change. But you need to route one more wire, and I don't really have enough space for that. I could do it if I was using USB-C connection between the halves. Then I think there is 5 wires. Or if I had 2 MCUs, one MCU on each side, then it would be no problem. But also maybe then I wouldn't be even needing this expanders at all. Maybe it would be enough inputs just on the MCU. Okay, so we have these two done. Okay, one more net. Let's do it. Pull up int. Okay, maybe make it a little bit tighter. Okay, so 10K, 10K, and one more over here. Okay, so we have SDA, SCL, and interrupt done. Okay, we have VCC, and we have ground over here. Okay, this one is left. So I think we have to... take a look. What was the address for the left side? Okay, this one. And what does it say? Okay, so the left side goes to the ground. Okay, we have no reset. Like this maybe. Okay, so there is no reset on this I2C expander, so we don't have to worry about this one. But all the addresses go to the ground for the left side. Righty. So maybe I can do it like this. Can I pull it a little bit down? Okay. I was reading something that you have to use this junction. Why it doesn't work? How about here? Maybe if I try to route it. Through wires. Okay, it made it. Okay, I read something that sometimes, or maybe it was a different version, it's not really making junctions on its own, but looks like it's fine. Okay, so far so good. Okay, let's take a look if there is a... Okay, so lucky us, looks like there is a footprint attached to it. That is so cool. Makes me wonder if there was a MCP 23 or 17. Let's take a look. Where was the browser? That was called Expand. Ah, there is MCP. Oh, that is so cool. Yeah, so okay, we are kind of saved in a way. We don't really have to bother with this. We don't have to make a new expander symbol. Alrighty. Okay, so far stream is working. Let's see if I'm getting a recording as well. Okay, something's happening. Cool. Alrighty, let's continue. So we have these done. Address is done as well. On the left side, everything goes to the ground. Okay, then we have to... Where were we? Was it draw IO? Or was it here? I think it was here. Okay, our connections for Chordie, all this stuff. Okay, so we are currently working on the left side. Okay, we have different naming over here. So I guess this one, this will be A0, and this will be B. Yeah, I hope I'm correct about it. Okay, so what can we do? How can we connect this stuff? I think we can create nets as well. So for example, for this one, let's say we take a net and we call this net, let's make it left. Let's make it A0. Like this. So we can create all of this. So A0 to A7, and this is bank B, hopefully. Well, if not, we can always swap it in firmware, but that would be, we still have to change some stuff in firmware anyway for this different expander, so that doesn't really matter that much. Okay, but we can do it like this. So if I make it like that with those nets, so from A0 to A7, and then it makes me think we should have a switch. Yeah, so then we can use a switch, like a generic one. It doesn't have to be even like MX or Chalk, because we won't be using footprint for the switch, because none of the switches is really reaching all the way to the PCB, at least not in this version. I already have a million different versions of Chordie in mind, like one just PCB, so maybe this one will be using the original footprint, but over here we don't really need anything. We'll be fine with just like a pad or something like this that we can hook up later on the PCB. So yeah, I think this will work. So yeah, then we can just use one switch. So this net will connect the output from the expander with one leg of the switch, and then the other leg of the switch will be attached to the ground, and this should do the trick. I hope this will work. As I said, first time. How do we... Okay, we can do it like this. It makes me wonder, like, would it change automatically? Let's say I make a label, let's say 1. Okay, it doesn't. Oh, okay, that is one more thing that I find different, because, for example, well, I'm not quite sure about the nets. Maybe with the nets it didn't really work this way. Maybe it wasn't like adding new numbers. I can't remember at this moment, but yeah, at least I think in EasyDA, if you chose a net and you keep adding nets, so you get like, you can change the number and then maybe you copy paste and it will change the number. Well, at this point it's difficult to remember. Anyway, we can do it by hand. So this will be A2. Five. 6 and 7. Okay, so did it like this? I'm still not happy. I was hoping I will get a A4, A5, okay, A6, 7. Okay, so it did something. We are missing only maybe I missed the 3. All right. Zero, 1, 2, 3 is over here. 5, 6, and 7. Okay, so this should do the trick. So this should be our bank A. So I can connect all of these. All right, so now we need more. We now need left side, we need a bank A. So let's add these. Okay, multiple. Like they couldn't make it a little bit bigger. Okay, add field. I wonder if there's any plugin or something like that that will do it automatically. Maybe I should look into it. Okay, so this is left underscore. Now we have B 0. Let's copy, paste, and 1 and 2. 3, 4, 5, 6, and 7. All right. 0, 1. Okay, that is okay. Maybe it's not that bad. 5, 6, and 7. And let's move this one where it belongs. Okay, so far so good. Still looks neat. Not much mess and flying components on the schematic. Okay, so I think now we can make... Let's make the keys somewhere. Okay, speaking of the keys, what kind of switch can we use? It doesn't really matter at all. Let's see, do we have any switch? I think any switch will do, and there's plenty. Oh, this one, 45 degrees. Do we need 45? No, not really. I think normal will suffice. Can I put multiple? Okay, how do I want to have it structured? Maybe from top to bottom. Can I kind of hide some names, value, reference? Okay, I can remove that. But the reference is kind of too high to my liking. Okay, I guess I can do it like this. If I copy, if I change it like that. Okay, so now it's fine. 4, 5, 6, and 7. Okay, let's take this fella. Okay, I guess we need one more. Shit, and we need to change the name either way. Makes me wonder what is this thing, and others don't have that. Ah, where did that come from? We need one more. I don't understand. Okay, so it looks like it doesn't like empty field, so it will just put tilde whenever I paste. Okay, never mind. So does it have a feature to align those symbols maybe somehow? Something like arrange. Symbol fields. Okay, so we can only flip, rotate. I don't see anything to arrange. Okay, so I think we have to do it by hand then. I can't see anything that will allow me to arrange those symbols somehow. Definitely there is a plugin somewhere. Okay, let's say it looks more or less okay. Okay, so okay, I think we still have to change the name either way, because this one, okay, we'll have to distinguish somehow, because once we have both sides done, so it's gonna be difficult to figure out which key is what. Okay, I think I have to change the name. So this will be SA something like this, or maybe SW, and if you make it like this, LA0. This one will be 1. So then we will know which net goes to which key. So LA0 will go to this switch, LA0, and so forth and so forth. And then this side we will just add everything to the ground. LA1. Zero, 1, 2. This one is 6, and this one will be 7. Alright, so we have switches on the bank A. Okay, for the left side, we have all the banks occupied. Alright. So let's do it like this. Like this, and then we can just add ground over here. Maybe I will just pull it out a bit more. Okay, so we have all the switches from the bank A. So that will be this one, A0, A1, R2, and so forth. 4, 5, 6. Ah, you're right, we don't have these two. But that is fine, because what I want to do, I would like to have all the inputs from the expander, I would like to have them pinned out. So just in case in the future, maybe when we are prototyping and maybe there will be a need to add one more key or add whatever to this, it would be nice to have those pins attached to some kind of a pad that I can solder something to it. This way I don't have to worry, and I can always expand the functionality. I can add some stuff. If I don't do this, if I don't have a pad for it, then it would be very difficult. I'll have to solder like a tiny wire to one of the legs. So having those pinned out will be great, in my opinion. Alrighty, let's copy this one and see what happens. Okay, it changed names, and that is not an issue. I mean, it's okay that it changed names, but it changed names not the way I would like it. So this will be B, and this will be 0. Switch left B0. Okay, that is correct. This one will be B1. B2. B3. Four. B6, and the last one is B7. All right. Okay, so we have left expander done. We have left switches done. Kind of. Okay, I forgot about these. Can I copy this? Okay, not so bad. Okay, so now we can connect those nets. So it will be almost like routing a wire from here to here, but less messy. Okay, so we have this one, this one. Okay, so anything else for this side? I mean for this bank, we have all the switches. So one side goes to the ground, the other side goes to the expander. So like A0 goes to here and so forth. I hope this will work. So let's do bank B. Okay, so we have bank B from here to here. B0, B1, B2, B3, B4, 5, 6, and 7. Okay. Always better to double check than cutting routes later on the PCB and attaching wires because something was off in routing. Alright, so what else do we need? Okay, we need a potentiometer as well, and this might be an issue. Okay, let's take a look if there is a potentiometer anywhere in the library. This is digital. Don't really want that digital one. Device. How about resistor? We have a variable one. Okay, so this is just a symbol right now. So we don't really have to worry about it that much. These are our networks. Makes me wonder if there's an SMD, maybe. Digital. Okay. Oh, not okay. This one looked okay. What I'm interested in is the footprint. Is there a footprint that we can use? Let's take a look. There's nothing for variable. Okay, we have some potentiometers. I have one that is 3 by 3. And that one is kind of small, but if I can find a footprint for that, I don't think I'll be complaining too much. I think that's the one. Holy shit, that is so cool. What others do we have? There's quite a number of different ones. Yeah, but I think that's the one. TC33X. If I remember correctly, that one is 3 by 3. This is kind of small at the same time. I'm not sure if I really want to use it. It's gonna be very difficult to solder. I do have it somewhere. If I can only find it. There you go. That's the one. It has a different name over here. But looking at I was browsing some data sheets before, and it looked kind of similar. It might be like a ripoff. Does it look something like that? It does. But trying to solder this might be a challenge. A huge challenge, actually. Makes me wonder if there is a footprint somewhere for one of these. Although this one, it won't really fit. I mean, we'll have to do it like through hole, and that's not what we really want. Yeah, we'll have to go like this. Unless we cut an opening. I had a somewhat similar PCB done for Chordie, but I never really ordered it. And for that one, I just did a cutout, so it would slide in like this. I could slide it like this, And then there was one path at the bottom. And then there was one path at the top. Okay, makes me wonder now. Maybe that wouldn't be such a bad idea to make a footprint like that. Well, we don't really even need to make a footprint. All we need to do is to just cut a hole for it and then put a tiny pad and attach a net to it, and that should do the trick. Of course, assuming I understand KiCAD correctly, so this kind of maneuvers are allowed. For example, okay, let's I don't want this one. Yeah, so let's take a look. I don't want to show this one. And this one, let's make it... okay, I think the name was okay. Okay, let's make it RV underscore left. I think it would be better to have it more like left. RV makes more sense, maybe. Okay, this one is kind of getting in the way. Okay, so over here, what we need to do, we need to connect one leg to VCC, or do we? Ah, yeah, right, because this one is... Okay, so we actually need more, we need one more. Let's put it over here, because, okay, we need one resistor like this, and then we need one more like that. So this one was supposed to be 68 ohm. So that one was like the base one to prevent the diode from burning. And then from here, let's delete this, delete this. Something like that. Yeah, so this goes to here. I think we have to change the name of this one because there will be two, right? So we also need one more. Okay, so let's make it... Okay, we don't really have too many collectors, so let's make it left collector, like this. And then we need to have one more for the right side, but so far we are on the left side, so let's leave it at that. Okay, there we need one no connect, so that will be over here. And then, okay, what else? I think I'm gonna rotate it one more time. I'm gonna rotate it like that. Can't really make up my mind. Okay, like this, and then from here. Okay, then we have anode, right, on the left side. So we need to have one more net. We're gonna call it left. Let's make it anode, or maybe A and D. Let's leave it like that. So we have collector and we have anode. Something like this. Can this be rotated? Okay, so maybe we can clean it up a little. I'm not happy how it looks like. Okay, so this is left side, the infrared sensor, right? So over here we have collector, which is pulled up. Okay, I think I messed up a little. Because looking at the schematic over here, so I think this one, we can't really call it a switch. Because this one actually goes from the collector, right? So it was something like this. We had a VCC, there was 5 volts, there was resistor, 10K. Then there was the transistor, if I remember correctly how to draw it, something like this. Yeah, so this is our collector. And we had a junction here, and this one was to B5. So we have to minus one switch, because all the rest is kind of a switch. Okay, I think we're gonna have to fix as we go. Alright, so for B5 there will be nothing like this. Okay, B5 is our diode. Okay, so how can we connect that? I assume if I attach this net to this, that will be an issue, probably. Well, if we only had a symbol for that. Let's see what happens. Most probably it's not allowed to have two nets on the... two different nets connect together, but how can we really do it the other way around? Well, I think it would be best if we had like a full transistor, maybe. Well, it's an issue that there is no symbol for this diode. Let's check again. Optical, fiber optic, sensor optical. So there is quite a lot of sensor optical. Okay, well, we can use one of these. Because technically the one that we've been using, it's these are two components in one chassis. So it's a opto transistor and it's a photodiode. So that should actually work. Yeah, I think this one will do. And of course, I'm not quite sure about it, if I can do it like this in KiCAD, but well. Okay, these are some other things that I don't really recognize. Transistors, sensors, proximity. Okay, that's something more or less what we need. Isolator. Okay, I don't think that's what we need. Display graphic, USB, microchip, sensor distance. So that's not this one. Okay, it's not here. So I think I will just use one of those transistors over there. Which one was it? I think this one should be... This one should do the trick. If we take a look, for example, let's look at this sensor that I was talking about. So yeah, as you can see, it's yeah, we have this is like an opto transistor, and we have a diode over here. So maybe we can, at least on the schematic, maybe we can do it with just those symbols. So I hope it will be okay. And then on the PCB, we won't be really needing any kind of footprint, because we won't be using the original footprint for any of those elements, because what we need some custom paths or whatever they are being called in KiCAD. So maybe this will work. Okay, so let's do it this way. Oh. As I said, I started with good intentions and now trying to cram in everything together. Okay, so... And the emitter goes to the ground in our case. Something like this, and then from here we can make a junction. Not sure if it's gonna work. Node to enable wires pins. Okay, so maybe it will work either way. So what we need left B5, right? B5 is our sensor output. Okay, let's do it like this. Okay, and we have a junction. Okay, so this looks kind of okay to me. Oh, maybe not so much, because it's kind of... Let's move this out of the way. So this will be our... This is our sensor. Like this. Okay. Well, maybe we can also add an diode, photodiode. Is there anything like this over here? The sensor. Okay, let's try LED. Okay, so many. Okay, is there a LED? What would be the name? Maybe IR? Okay, one of these should do. Okay, whichever. Let's check this one. So let's remove this. So I think it should be something like this. Let's not show the name. Okay, let's change this one to be left IR anode, maybe. No, left IR like this. Okay, so this one and the ground for it as well. Okay, I think it's okay. I don't really know at this point. Like, the schematic looks okay to me. So maybe it won't explode. Okay, so let's take a look at the connections. So okay, left side. So on the left side, okay, we're gonna have a 4 and then 5. It will be unconnected. So I have to remember about it. So then we can put them like somewhere close to the expander for like the future use, just in case. Maybe we'll add some more keys in the future. I don't know. Yeah, I was also thinking, because maybe it would be possible to even change it even more. Maybe we can have one more infrared somewhere over here. So then when my hand is like this, so I have normal keys over here, but when I touch the ball, the infrared will trigger, and then it will change. For example, maybe these 3 keys will become the mouse keys. And yeah, this is kind of okay, maybe. I had this kind of at a design some time ago on one of the older keyboards, but back then I didn't really work that well. Then it will have to automatically switch those 2 layers between the normal keys and the mouse keys. Yeah, but we can try. If we can manage to get the PCB working, then it should be easier to do this kind of testing. All right, so we have left side. I think it's done. Okay, one more thing. We forgot about one more thing, and this thing is a capacitor. Maybe not that much needed, but I think it will be worth having. Okay, let's take a look. What do we have over here? Okay, this one looks okay. Let's add this fella. It's kind of huge. How about this one? What does it mean it's small? Okay, it's smaller. Okay, so I prefer this one. Let's remove this. This might be the worst PCB and the worst project in KiCAD. Oh, hello there, SG District Homes. Came here to help with the PCB. How was your lunch? Binge? Yeah, good that you are here because I have no idea what I'm doing in this program. Too full to move. I guess that's good. Okay, value, it's gonna be 100 nanofarads. It doesn't show. Okay, I think I changed that. Let's show the value. Okay, let's take a look what kind of footprint we can have. Okay, we have SMD. Okay, let's make it 08, 05. Okay, this one looks good. So just like before, because I have a lot of 08, 05, so this one will be alright. Yeah, and this one has bigger pads compared to this one, so should be easier to solder. Okay, so we can leave it like that. Let's change this one, it's kind of getting in the way. Okay, let's do it like this. Okay, that was stupid actually. It can't be connected like this. Oh, come on. It has to be to VCC. Oh, come on. Maybe we can move it to the top. Like this. Okay, let's move it together in line, and this goes to the ground. Okay, am I doing this correctly? Let's refresh. Yeah, so it's should be something like this. So from here, we're gonna be needing one more net. Let's call it left underscore let's make it expander VCC. I can't make up my mind about this length of this thing. Okay. So over here we need to add we need to use this one. Let's rotate like this. Okay, so this way we'll have a filtered output from here to VCC. Okay, ground. What else? What else? Okay, so do we have everything already done? Okay, we have pull-ups over here. These three. SDA, SCL, and interrupt. Then we have stuff for the infrared. So actually we don't really need a footprint for that. We can do it later on the PCB. We have infrared light, we have those resistors. I really hope it's gonna work together. Okay, then we have our lonely encoder. So there will be more switches that we have to remove from here. We take a look at the connections. Okay, so we're on the left side. Okay, so there will be two of these actually. Because one will be for volume and the other one will be for scrolling on the left side. So I think I can add one more. Okay, let's change name for this one. It's gonna be a left underscore. Let's make it left encoder. Let's call it horizontal. Okay, so left encoder horizontal. That's it. And this one we can change to. Well, we don't really have to call it left, but maybe to keep everything correct. So this will be left encoder, and this will be volume. Oh, let's make it vol like this. All right. So for the horizontal encoder, we have no connection on the switch. So we're gonna do it like this. Then if you look over here, okay, so we have B3 and B4. Okay, so connection A is gonna be our B3. So we have to remove it from here. B3 and B4 will be over here. We have to take it away as well. Okay, so no switch over here and no switch over here. B3 and B4, and then common one was ground. Let's add ground over here. Let's rotate it. Something like this. Okay, and one more ground we can already add over here. Okay, and let's take a look. So volume was B1 and B2. So B2 and B1. So I hope I won't mess it up. So B2 will be, should be technically our B output. And then we have more because we also have the switch. So this one goes to here. Okay, B2 and B1, and then also we have B0. Now let's add it over here. Can we do something like this? Okay. So I think this ground I should maybe pull a little bit higher. Or maybe something like this. Because there will be a junction over here, because both will connect to the ground, one side, and then this one was to B0. And this one was our A to B1 and B to B2. So we can get rid of those switches as well. All right. So far so good, I guess. Do we have anything else that we still have to connect on the left side? Why physics lesson? You don't understand anything? Okay, what a mess. Was supposed to be so pretty. Okay, I think this is all for the left side. We have encoders, we have all the switches, we have infrared. We have I2C expander as well. You know what? Maybe we can dump this. It's so annoying. Looks like I'm not a big fan of this app. Let's do it like this. We need a ground over here. Something like this, if I am correct about it. Okay, so expander is done. What else? What else? What else? Infrared is done as well. Maybe 5. We have both resistors. I think I should rename those. Okay, something like this. Okay, we have no footprint over here. That should be okay, I suppose. Okay, let's see what happens if we update our PCB right now. Okay, what do we have over here? Update PCB from the schematic. Let's see what happens. What does it mean, fully annotated? I don't understand what is wrong. Let's see. Okay, so it looks like we have something that is not fully described. It would seem like we have some hanging wires or something like that. But it doesn't seem like it. Is it complaining about those switches? What will happen if I just let it annotate? Ah, okay. So that's what's the issue. So it needs to have numbers. Okay, I'm okay with that. Okay, let's see what happens now if we update from schematic. Okay, so some stuff it did add, some stuff it didn't. Okay, this one was intentional, wasn't it? Errors. Ah, shit. Okay, so this is all of the stuff that we have over here. Okay, most probably if we run a DRC check, is there like a check that we can do over here on the schematic? It makes me wonder if there should be something that will check, like if we have everything connected properly, if all the nets are connected and all this kind of stuff. Maybe this one? Okay. I think I know what's wrong with it. It needs some kind of a power source. I have power flag. Would that work if I do it like this? Okay, and this one is what? Does it need all those strange power flags everywhere? Let's take a look. I think I saw something in the docs. Okay, not this one. Getting started. Oh yeah, exactly the same thing. Okay, why does it need those power flags? Oh, okay, so we just have to add this. Well, that one was okay. Kind of odd that it requires such a gymnastics to make it work. Okay, so if we add this one here and we add one more to the ground, let's say we add it over here, so this should make it happy from what I understand, because these are the same nets. We have ground, we have plus 5 volts. Okay, let's take a look what happens now. If it's still gonna complain. Okay, don't need... Alright, there's a warning. What is wrong? Uh-huh. Okay, that is not an issue. And this one, what's wrong with this one? Pin 1, power output line. Okay, I don't really know what's wrong with this one. I guess it's something about this output. One second, I'll be right back. Okay, looks like delivery. So does it mean we are clear and good to go with this side of schematic? Let's see what happens if we update. We have 11 errors. Okay, so we have no footprints for those switches. That should be fine. Okay, let's take a look over here. Is there like a... okay, design rules checker. Okay. Okay, 25 errors. Oh, that's quite a lot, but... I was wondering if it's checking if there is a connection or not. Ah yes, unconnect items. Okay, so now the question is, since this is the left side, so we have to keep all the elements on top. Yeah, I guess, because there will be no space on the bottom, like the bottom plate of the keyboard. So let's say we have the keyboard like this. So let's say that is the PCB, like so. So I will have all the components over here. So then I have all those openings like this. So there will be enough space for all this stuff. Yeah, we can't really put it like on the bottom of the PCB because there is not enough space, and we don't really have... Well, if you really want to, I think we can fit over here. But yeah, I'm gonna do it. I'm gonna do it this way. I'm gonna put all those elements on top. So let's move it kind of briefly. Yeah, for this, I think... Okay, volume. Okay, volume we'll have to remove the footprint anyway. For this one, I think we should be good. Okay, let's check. Can I position? If I want to position to here. Is it gonna place it over here? It did. Okay, so I think this one is okay. So we have those elements on the bottom. If you take a look at the PCB, where is it? 3D view. Yeah. We have holes everywhere. Do we? Can't really see. Ah, okay, it's okay because these holes are meant for if I would like to rotate the whole thing. So this is mostly for the just for the encoder. Okay, but looks more or less fine. So we have this one thing. I haven't done anything here. What is this thing? Okay, that's the transistor. Okay, so this one, and okay, we have no diode anywhere. So we have the capacitor. Where is it supposed to go? Okay, over here, 5 volts. We have this resistor over here. That is the pull-up. What is that? Oh, so this, okay, so this is our infrared. So we have to, this one will be skipped as well. I think we can skip the names of this. I want to show. All right. So this one is also pull up. Should be here. What's that? Okay, this one is for the infrared. This one is pull up as well. And this one is pull up as well. It should be over here somewhere. Take those two, move them down. Give it a little bit more space. Like this. This one, the name is kind of getting in the way. We don't really need to know which one is it. Okay, maybe let's leave this one. Okay, so we have quite a lot of paths to add. Okay, maybe we can start with the infrared. So for the infrared, we have some stuff over here. B5 ground. Makes me wonder. There should be a resistor as well. Connect to it, right? Move this over here. Oh yeah, this one. Okay, that is fine because B5 kind of odd. Oh no, it's okay, it's okay. I was just wondering if it's correctly designed, but yeah, it's okay because this one goes to expander and to VCC, so it's all good. Okay. Now let's take a look. So we need some kind of a pad. We have a test point. Okay, we can either make it round or maybe we can do it square. Oh, there's quite a lot of these over here. Okay, plated hole. Okay, that is nice. Do we need a plated hole? Should we make a hole or should we keep it? No, we need a pad. We definitely need a pad. Let's take a look at this one. Okay, this one is round. Okay, let's use this one. This one is 1.5 diameter. Let's take a look how big it's gonna be on the PCB. How do I add it? Okay, let's take a look. Maybe this one, 2 millimeters. Okay, I think I will go with 2. Okay, question is, can I attach a net to it? This will definitely do the trick. How can we change the net for this thing? If we go into preferences, edit footprint. There is something else. Editor. Okay, that is pad number 1. Okay, can I add a net to it? That is interesting. Let's take a look. What do we have over here? Some wires. Okay, is my plan flawed a little? Because let's say I would like to add it over here. Let's see if there is something called test pad. There are test points over here. Okay, so maybe I should do it this way. I'm not really familiar with this app this well. But for example, in EasyEDA, I could just add a net on the PCB. I didn't have to go back to the schematic to have it done. Righty, let's see. Okay, let's add this one and see what happens. Okay, but this is a test point. Okay, what stuff do we have over here? Okay, so we can change the footprint. we can do it. I think we have used this. Oh, this one is square. I think we used this one 2 millimeters. Okay, so this will add a path for us. Okay, so maybe this is the way to do it. Okay, so we have a test point. Although, okay, I'm kind of getting ahead because over here, okay, but we would need to have a ground as well. Okay, because for this one, so on this side we need to have the ground paths anyway. I'm wondering now if I can have it like that. Like, can I just drop a path and say that, okay, this one is ground. Connect to the ground. And these are net classes, so that doesn't really bother us. Okay, so we can't change anything here. It makes me wonder if there is something like we can connect different stuff. Rules checker, update. Okay, script console, nothing that I need. Okay, footprint library browser. Okay, so clearly I can't really change it over here. So does it mean I need to have a test point like this? And let's add ground to it. Okay. Let's take a look. I don't think we need to check electric rules. What is that? Ah, okay, so it's the same stuff. Doesn't bother us. Alrighty, so let's do an update. What happened? Same number of errors. Okay, but we have this one thing. Okay. Okay, so right. So now I have it connect to the ground. Makes me wonder if this can be changed somehow. It looks like there is no way. Or maybe I'm not seeing it right now. Okay, so looks like we have to do it this way. Okay, so let's go back. Let's go back. So if we just copy and paste. I wish there was like a global setting where I can disable these names. Okay, let's try to move this. Oh, okay. Select all. Okay, over here. So I'd like to move it. All right, so looks like we need to do it this way. So we need, okay, we're gonna be needing quite a lot of these. So we're gonna be needing 2 for the infrared. Then we're gonna be needing quite a lot for the switches, right? So we need at least yeah, right. So okay, I think we can do it a little bit different. Okay, let's take a look over here. So instead of having those switches, maybe I can change it and I can add 2 paths. So okay, let's remove this one. Let's copy this path. Okay, this one's a little big, a little too big. I think I saw a small one. Test point small. Okay, this one looks nice. Yeah, this one will be perfect. Okay, I don't want to route it just yet. I just want to get rid of this long name. Yeah, so this way we will have one path will be for the ground. So this is how we're gonna attach the switch. So one leg of the switch will go to the ground. The other leg will go to one of the outputs. So it looks like we have to be a little bit more organized. Over here, I don't want to route it. Alright, something like this, if I am correct. Yeah, this should do it, so then we will have no issues. I hope we will have no issues with it. Trying to do all these connections to the switches, various switches. Alright. So much work, I have to delete everything. I don't think I should bother too much with the names of those things. I hope I will be able to change the footprint for all of them in one go. Okay, so something like this. I think it would be even better. It makes me wonder if I can select just specific type. For example, in EasyDA you can select just diodes, or you can select by the net name, or by the pin name, or by the size of a footprint, or this kind of stuff. Over here I don't really see anything. I can just select all, unselect all, find. Okay, so that's just one search pin, hidden field. Okay. And there's no way to select all of them. Okay, let's do it like this. Okay. Pin and positions, orientation. Oh, it's so shitty that I can't change, like, I can't change the visibility of those things. Maybe there's a shortcut somewhere? Okay, also that is a little bit annoying. Okay, so that doesn't really do much. Okay, I give up. I don't know if I can change that or not. But I have to go like one by one. So annoying. Oh boy, that is really annoying. But this, I hope this will work. Looking at those paths, so now we have them in the schematic. They will also show up on the board. All we need is to just add a proper footprint for all of them, and hopefully this will do the trick. So then we can route it on the PCB. So maybe we are not that much lost in it. Maybe there's a hope that we can get this PCB manufactured. Okay, the question is, can I attach footprint? No way, I can't even attach footprint to all of them. Holy shit. I think it would be easier to just copy and paste at this point than replacing all of them. This. Do we have over here? Okay, the name, footprint is the same. I hope this will work. So one side to the ground and one side to the expander. Okay. I wonder if there's anything that we have to check. It's still the same stuff. Okay, let's take a look right now. Let's update from the schematic over here. Okay, we have one error. Okay, no footprint. Okay, so this is our resistor. We don't care about it. Oh, we have so many of these. Yeah. Okay, so these test points are for infrared. Please tell me I can hide the names. Okay, can't see the values. Okay, oh, that's nice. Over here I can distribute, but there was no such feature, I think. Or was there? Yep, there is no distribution over here. Makes me wonder why. would come handy. Okay, how do I get rid of all those names? Okay, I see I can also filter select. Alright. But this won't really help me over here that much. If I group it, I was hoping maybe if I can make a group out of them, they will all share the same like preferences window, so I can change all of them. Looks like not. Okay, so I can, alright, so maybe it's not that bad. So I can do it like this from what I can see. I can change it. Okay, over here it has a net name. Let's do it like this. Let's select footprint. Okay, I think I know what's wrong. So maybe I could have done it before. I just had a, I think I had a select for footprint only. And now, now I can select this one and I have access to the net over here. Yes, I didn't really have to bother with that stuff on the schematic, but I think it looks okay. Okay, so let's change that. Let's do footprint only. Let's select this one. And let's say we don't want to see this and we don't want to see this. Okay. And now I can select these. And where is this feature? Select. Okay, let's do all items. There was this, okay. This one, copy path properties to default. Paste default path properties to selected. Maybe let's do it like this. Let's do footprint. Let's move this one away. Select this one. And if I click like this, oh, come on. Why this is not available anymore? if I copy. But this is only the pad. I would like to change the whole footprint. That doesn't really satisfy me. It's not about the pad only. Where is this text? Why am I keep seeing it? Okay, at least I got rid of this one. Oh, don't tell me I have to change all of them individually. It's such a pain in the ass. Let's see if there is any help on the internet. Okay, so we need a plugin for that. Oh my god. Now it's kind of retarded. Such a simple functionality. It should be by default. There's like a plugin manager. Maybe you can find something interesting. Where do I find this plugin manager? It's here. Plugins, packages and updates. Okay, this one's interesting. So view, properties manager, a new panel. Okay, we have a new panel. You can control click. Yeah, but we can't change visibility anyway. Position locked, reference value, and that's it. And the stuff that really matters is not available. It doesn't look like all of them are listed. Yeah, indeed, visibility is not present here. Okay, I think I will have to stop on this. I need to check up on some plugins that will make this easier, because doing everything one by one, it's a pain in the ass. I'm kind of surprised that this app doesn't have this kind of functionality. It's so obvious. It should be by default. Or maybe I'm just doing something wrong. Maybe I just don't know how to change it. Yeah, like I have properties right here, but it's not all of them. Maybe there is some other stuff. A net inspector. Okay, there's nothing else that we can check. Okay, I'm gonna stop on this. I really need to find some kind of a plugin to make this easier, because it's unbearable to do it by hand. Okay, I'll be back on Friday. Hope to see you on Friday. Yeah, tomorrow most probably I won't be able to stream, but stay tuned. Just check the YouTube schedule if it's updated for what date. And yeah, for now, thank you for watching. Have a great afternoon, evening, wherever you are. Have plenty of rest and come back on Friday. Bye bye. Thanks for watching.